Jai Hind everyone. I am Vivek Kumar Pansari, Assistant Professor in Department of Mechanical Engineering at Ajay Kumar Garg Engineering College, Ghaziabad. In the lecture series related to Fundamentals of Mechanical Engineering and Mechatronics, KME 101T and KME 201T. Today I am starting unit number 4. So, earlier I have already gone through 3 units. So, today we are focusing on unit 4, which is related to measurement and control system. What is the purpose of this unit? The question comes here, why we are going for measurement and control? What is the purpose of control? For the effectiveness and efficiency of any system, we need certain controls. A system will perform in a desired manner only and only we are putting some control. Okay? And control, how it is possible? If you are having some data in your hand, and then data will be available through the measurement. So, that is why this particular unit in any system, either it is a service sector or it is a manufacturing sector, either it is the field of engineering or any other field, wherever we are going for improving the system, for improving the effectiveness of any machinery, for improving the effectiveness of any service, we need to measure something. We need to measure something. So, that is why it is necessary to deal with measurement and control system. Here we are not talking about the general measurements, because we are talking about the engineering field. So, the thing comes measurement related to engineering. The very famous quote, whatever exists, that exists in some amount. We all agree with this. And if it exists in some amount, it can be measured. So, we can't say these things can be measured, these things can't be measured. Everything which is existing in this universe can be measured. We may be knowing the methods of measurement, we may not be knowing the methods of measurement, but we can measure. Okay? So, that is what the theme is. So, now I am coming to the very basic definitions related to this particular unit. First one is the metrology. So, metrology is the name given to the science of pure measurement, the name given to the measurement techniques. Completely it comes under the umbrella of metrology, the science which deals with the all kind of measurement. And if I am talking about the engineering metrology, basically we are dealing with the length and angle. And it is defined as, measurement is defined as the process of numerical evaluation of dimensions or the process of comparison with the standard measuring instrument. This is what the metrology or measurement is. Why? Now, the question comes, why we are going for the measurement? Why do we want to measure something? So, as I already told, for improving the effectiveness, for improving the quality of any system, we need to measure. So, whatever we are delivering, either in terms of goods, either in terms of services. Okay. So, we have to check the quality of that good or service. For that, it is necessary to check the quality. So, if we want to check the quality, what we are promising, is it delivered or not, then we have to measure. The answer is measurement. Another thing, to check the tolerances. In manufacturing theme, we decide some tolerances, we decide some permissible limit. Under that limit, that component is accepted. Beyond that limit, that component is rejected. So, how we can do the selection or rejection? Only on the basis of measurement. So, to check the tolerances. Then, to allow statistical process control. What is this statistical process control? SPC. Okay, it is also the technique to perform the quality analysis, to perform the sampling analysis, and for that again the measurement is necessary. So, that is why measurement is the necessary part of engineering or in any service industry. How do we measure generally? What do? We have some scale, we have some standards, and through that scale we compare that quantity. Okay. So, the basic procedure of measurement is the comparison, process of comparison. With what? With some standard and known quantity. If I have to measure the dimension of this pen, then what will I do? Obviously, I will take some scale, I will take some 6-inch scale or 1 feet scale. Through that I can measure, on that the standards are given. So on that basis I can measure the dimension of this. So it's comparison with the some standard and measured quantity will be come out in the result. So that is the basic procedure of measuring anything. And why we are doing? So there are two requirements which are to be satisfied to get good results from the measurement. How can we ensure these two things? The standard must be accurately known and internationally accepted. Whatever the measuring system, whatever the measuring instrument we are using, that standard must be nationally, internationally, domestically, it must be accepted by each and everyone and known to everyone. The apparatus and experimental procedure adopted for comparison must be provable. It doesn't mean that we are doing the measurement at our own and it is not accepted by, because now we are in the global era. So here our measurements, our procedures must be accepted by each and everyone, and the process of measurement must be very clear. This is what the comparison with what? Comparison with some standard. Standard means known quantity. Need of measurement. This can be a question. Okay. Why do we go for measurement? To establish certain standards. Now it is clear, because when we measure something, when we do the certain measurements at regular intervals, then we can establish certain standards. This is what the desired thing. Interchangeability, another purpose of, because if we know the dimensions of parts, then we can perform the interchangeability between some parts if the exact is not available. Customer satisfaction, whatever we are promising, if we are delivering that quality, if we are delivering that measured quality or quantity, then obviously indirectly the customer satisfaction is ensured. To validate the design, so if we are producing the goods as per the design, then we are doing the validation with that. Physical parameter into meaningful number, true dimensions, and the last but not the least, this is what the basic purpose of the measurement, to evaluate the performance. So this is the way we go for we need the measurement procedure. We can take the example of any class also. We go for measurement, we go for the evaluation procedure, we conduct certain tests, we conduct certain sessional tests, we do all these things. Okay, the purpose is to evaluate the performance. For what purpose? To establish certain standards and to ensure the customer satisfaction. It means the quality education is ensured. So this is what, so the way which we are doing in our classes, that is the measurement. That is the other type of measurement, but in engineering field we do some other kind of measurement which is related to the dimension basically. Okay. Then I am coming to the how do we go for measurement? What are the different ways through which we can perform the measurements? Okay. So there are three different categories in which we can classify the methods of measurement. One, direct and indirect measurement. Another one is primary and secondary and tertiary measurement, and contact and non-contact type of measurement. Now we are not restricting ourselves only up to the measurement of length, mass and time. Now we are increasing our dimensions. Now we will be able to ensure the measurement of temperature, we are able to measure the pressure, we are able to measure the humidity. So many things which we can measure. So it is not necessary here only we are talking. In this particular unit we will be talking about many things which we can measure with the help of different type of devices. Okay. So in all these categories, direct, indirect, primary, secondary, contact, non-contact, we can measure many things. So what basically the first one is direct and indirect measurement. Direct measurement is what? The value of the physical parameter is determined by comparing it directly with the different standards. Okay. What it is? What is the meaning of this? If I have to measure this, the length of this, then through some scale I can directly measure that. So this is directly available to me. Okay. And the physical standards like mass, length, time can be measured by direct measurement. So this is what the direct measurement. No other means is required. No where we have to transmit the data. No where we have to send the signal. So this is what the direct measurement. Only the observer and the scale is available, then I can measure that. Okay. Indirect measurement, the value of the physical parameter is more generally determined by indirect comparison with the secondary standards through calibration. Now I am coming to the point. I have to measure the temperature. If I have to measure the temperature of this room, what will I do? I have to go with some thermometer. I will put some thermometer. So thermometer tells the temperature in what terms? The mercury is rising. Mercury is rising in the tube, in the thermometer, and that length we are measuring. So first measurement is the measurement of length, and that thermometer is calibrated in such a manner that it is giving you the reading of temperature. So this is not the direct measurement. Directly we are measuring the length or the rise of the mercury in the thermometer, and indirectly we are getting the result through the calibration in terms of temperature. So this is the direct and indirect measurement. Okay. The measurement is converted into an analogous signal which is subsequently processed and can fed to the end device at present at the result of measurement. So okay, I think this point is clear. Then the second type of classification is based on primary, secondary and tertiary measurement. So what basically the primary measurement is? The value of physical parameter is determined by comparing it directly with reference standards. The required information is obtained to sense of sight and touch. So very simple. Through example, it will be more clear. Matching of two length. Which one is larger? If I say which one is larger, directly you can say this is the primary measurement. You will say the sir, pen is larger. Okay. Estimation of temperature difference between two components of the container by touching it, by inserting the finger. If this remote is at some different temperature, this is at some different temperature, then I can feel that. I am not asking the temperature measurement. What is the temperature in degrees Celsius is there. So only the temperature difference. Use of bean balance. Okay. Measurement of time by counting the numbers. 1, 2, 3 like this. So this is the primary type of measurement. We are not doing any transduction here. And secondary and tertiary measurement. Measurement are the indirect measurement involving band transmission are called secondary measurement. As I told that if I have to measure the temperature of this room, that is not directly or primarily available with me, that will be available with band transduction, band transmission. It means length, rise of the mercury is getting converted, calibrated with respect to the temperature rise. So that's what the secondary. So if band transduction, band transmission is there, then this is the secondary type of measurement. If more than band, then it is the tertiary measurement. So primary, directly which is available to us, nothing else is required, no transduction of signal is required. Secondary and tertiary, if we are performing band transduction, then we will say that is the secondary measurement technique, or tertiary if we are doing more than one. Okay, so and involving two convergent or two transmission, that known as tertiary measurement. So the convergent of pressure into displacement by means of B allows, and the convergent of force into displacement, pressure measurement by manometer and the temperature measurement by mercury in glass tube thermometer. These are the examples of secondary measurement. The measurement of static pressure by Warden tube pressure gauge is a typical example of tertiary measurements. Warden tube pressure gauge is the instrument through which the pressure can be measured. So in which, because of the change in pressure, the Warden tube expands, and that indicator, ये indicator change होगा, indicator displace होगा. So because of the displacement, so because of the pressure, the Warden tube is expanded. Because of the expansion of Warden tube, this indicator is rotating, angular displacement. So there are two transduction involved. So that's why we are saying that is the tertiary measurement. So in detail we will discuss this in later videos. Okay, what basically the Warden tube pressure gauge. So here at that point of time we can understand that there are two transduction, pressure into the expansion of Warden tube, and Warden tube expansion is converted into the angular displacement of the indicator through which we are getting the information ki how much pressure is there. So this is the primary and secondary and tertiary measurement. Another type of is contact and non-contact type of measurement. So where the sensing element of measuring device has a contact with the medium whose characteristics are being measured, and in non-contact where the sense doesn't communicate physically with the medium. So the optical, radioactive and some of the electrical and electronic measurement belong to this category where the direct contact is not possible. Okay, if I have to measure the magnetic field strength, then magnetic field directly I can't get from the touch. Okay, optical luminosity of this room, that directly it is not available. So this is the non-contact type. Okay, measurement is there. Now I am coming to the what basically the measuring system is, how any instrument works. Okay. So there are certain basic elements through which an measuring instrument works. Primary sensing element, variable conversion element, variable manipulation element, data transmission element, data processing and data presentation. So these are the 6 basic processes which are occurring in a measurement through any instrument. Okay. Now what these are? Primary sensing element, an element that is sensitive to the measured variable. The sensing element senses the condition, state, value of the process variable by extracting a small part of energy from the measurement and produces an output which is proportional to the input. As I took the example of thermometer, so here again I am taking the example of digital thermometer. Okay, if this is the digital thermometer, what it will do? Primary sensing element. Obviously, the tip of this thermometer must be like this, which is sensitive to the temperature. So that tip, that bulb is the primary sensitive element. That's what written here, an element that is sensitive to the measured variable. The quantity which has to be measured, for that it must be sensitive. Okay, so that is the primary sensing element. Then what is required? Only by sensing can we go for the measurement? No, that sensed signal must be converted into some readable quantity. Okay, so for that certain processes are required. So the first one is the variable conversion or transducer element. So that element converts the signal from one physical form to the another without changing the information which we have received in form of input. Examples such as the Bourdon tube and bellows which transfer pressure into displacement. This can be a one. So pressure को displacement में convert कर रहे हैं. Proving ring and other elastic members which converts force into displacement. So we are sensing the force which is getting converted into displacement. We are sensing the pressure which is getting converted into displacement. We are sensing the temperature which is getting converted into the rise of the mercury in thermometer. So this is what the variable conversion element. So one type of sensed quantity is getting converted into another type of signal which is processable. Manipulation element. Now, if the signal is not that strong, that it has to be amplified. So manipulation element, it modifies the direct signal by amplification, and amplification by some constant, so that we are not changing the meaning, we are only amplifying so that the reading is possible. So this is what the purpose of manipulation element. Then data transmission element, an element that transmits the signal from one location to another without changing the information. Now the signal which is manipulated, it has to be transmitted somewhere, and it may be transmitted over long distance from one location to another or short distance. Then data processing. Now the data which is in form of observers reading, that has to be processed. We have to make that information readable to everyone. So data processing is required. So an element that modifies data before it is displayed or finally recorded. So data processing may be used for such purpose. Correction to the measured physical variable to compensate or scaling, non-linearity, zero offset, convert the data into useful form, calculation of engine efficiency from the speed, collect information regarding average, statistical and logarithmic values. So this is what the data processing element which is performing this. Then data presentation, an element that provides record or indication of the output from the data processing element in a measuring system using electrical instrumentation, an exciter and an amplifier are also incorporated in the circuit. So by this way, the data presentation, the display where we are getting the information, how it is doing. Now, if I am an observer, I have to observe the temperature here. Okay. So for measuring the temperature, first it will be sensed by primary sensing element. Okay, is it okay? Then that temperature which is sensed here, it has to be converted into a processable signal. Then if this processable signal is a very small quantity, then it has to be amplified. So variable manipulation element. Then this data which we have sensed and processed and amplified, it has to be transmitted somewhere in the circuit. So data transmission element is required. Then data processing, which can be easily displayed, which can be easily read by anyone. So data processing is required here. Then data presentation, and now the observer, I am able to read the temperature here. So this is what the measurement and control system introduction. How do we go for different type of measurement? What are the different type of measurement? Now in my next videos, we will be covering different physical quantities, how to measure pressure, how to measure temperature, and what are the basic concept behind the how engineering is involved, how mechanical engineering is involved, how electronics and sensors and instrumentations are involved. So here I laid out only the procedure, only the basic concept of measurement. So thank you very much for watching the video. Thank you.